Hi, Sasha. Welcome.
Hey Adam, thank you very much for the invitation. Really excited to be here today.
Yeah, perfect. The reason is I wanted to know what was your first computer.
My first computer, let me think. So my first computer that I actually owned was a Commodore 16. That was like ages ago. My grandma bought me that one because this time Aldi had like a sale of those Commodore 16s. And before that, I played around with a Schneider CPC, and I wanted to have one of those magic machines. So my grandma bought me this for Christmas, and it was an amazing Christmas present. So my mother actually was not that happy about the computer, but yeah, I really enjoyed it.
Why not? Because of playing, right? Or
Exactly, yeah. So I mean, her she only thought about okay, you can only play with this machine, but after 2 years, I started playing around with it more. Like, let's say, how is this magic machine actually working? So I started coding first basic. First basic programs, and then started adopting other languages like Pascal and C and so on.
what was your favorite game?
This really depends on the machine. So on the Commodore 16,
Yeah.
it was Fingers Malone.
Okay.
It was like a platformer game where you had like one screen, and then you had to go to a certain exit. It was really really hard, to be honest. So I spent quite a lot of time playing that, and then I got a Commodore 128. And
Wow. From C16 to 128. No C64.
yes, no, I mean, the it had this C64 mode, which I often use for playing games, obviously, and the C128 mode was mainly for coding stuff.
Were there no
So
games for 128?
not really, not too many. I mean, there were certain versions for it because it had enhanced capabilities when it comes to faster CPU and so on, but only a small amount of games really took advantage of that. But I mean, on the C64, I really loved Terrican. That was amazing.
Terrican. Is this with the train?
No, it was basically like a platform shooter where you had this. Manfred Trenz implemented this,
Okay.
and he basically did everything. So that was an amazing experience on the C64. So we had like super large sprites and a lot of enemies. So it was really amazing experience.
I remember two other games. R-Type,
Of course.
R-Type, and Magmax on C64.
Magmax, I don't know this, but R-Type, I think this was also a Manfred Trenz game.
Oh, really?
Yeah, I have to look this up, but I think it was also implemented by Manfred Trenz.
We have to do some research what Manfred is doing right now, right?
Absolutely.
It would be interesting to know. Yeah, okay, so you played games with the C16. You started the coding on C16, or was it later?
Yeah, I started coding on the C16. So 2 years later with Basic. So that was really a great thing because the C16 also shipped with a simple basic tutorial, which was on tape, so you could load it and then start coding.
And why you started? I mean, so you play game, you are happy, and what was the idea to start coding?
So the basic idea was I wanted to find out first, of course, how this magic machine is actually working, and how I can implement my own ideas, how I can create my own games. So this was basically the idea
Yeah, okay.
behind it. And then I noticed, hey, it can also help me at school. So yeah, which was super useful.
So what was your first? Oh, how you started programming, or what was your first program?
Standard Hello World, I think.
Okay, and then later, what was the most impressive thing you did on the C16?
On the C16, I was. This is a good question. I don't think that it was really impressive. Just
Or something more complicated? I don't know. No, beyond Hello World.
yeah, something for my math lessons. I think at the school. So to do some math training. But I really started serious coding on the Commodore 128. So I also implemented a game, which was the first software that was the first software title that was released that I had it written. So maybe you remember those old disk magazines where like shareware software and public domain software was released. So and then one of those magazines published it, and one of my colleagues actually is very deeply into retro computing, and he found an online version of it. So the game is still out there. And
Your
so
game?
Yes.
So you wanted to
still
tell
out
me
there.
let's second. You wrote a game, and the game was published.
It was published, yes.
That's crazy.
We got, like,
Yeah, but I mean, how long it took, from beginning to publishing, and you wanted to create a game, or was it just accident, or what was your mission with CC128?
It was basically an accident. So I noticed, okay, there is a sprite editor that you could use, that the basic implementation for the computer was just really designed to do some graphics related stuff. So this was really easy to use. And then I thought, okay, why not code something and try to get it released.
Okay. What was the name of the game?
It was called Pommes, which translates to French fries. So you were this little French fry, and you had to go to a certain exit, and then there was like ketchup and then mayo and so on coming from the upper part of the screen, and
Sounds like fun. So we need the link to the game.
Yes,
put to the show
absolutely.
notes. But it's cool, and you made some money with it, or?
Yeah, it was like 100 Deutschmarks, something like
but
this.
Back then, 100 was like maybe 200 euros right now, right?
Yeah, it was quite good.
And how old were you?
I think 12 or so.
This is incredible. So you're a natural born coder. So with 12, you publish your first game.
Yeah, but I mean, this was a lot of fun. And
you wrote the game in BASIC?
Yes, it was completely in BASIC.
And how you got the ideas? I mean, you have to have some basic skills, timing, and maybe even kind of events. I mean, there were no events, but goes up at least or something to make it more structured. How you got the ideas?
So I mean, in my neighborhood, there were also two. I had two friends in roughly my age, so we were basically spending a lot of time in front of the computers, and we were sharing some ideas how you could implement stuff like this. And then we came up things like, okay, you need this is basic control loop, right? So for a game, you need to implement collision detection, and so on and so on. So then we put those pieces together and started implementing games. Okay,
cool. Then I'm already curious what happened afterwards. So you published the game, and what was the next idea? I mean, you were surprised that it was successful, or what? Or you knew that it was going to be successful, or what?
No, not really. I was just sending it over, and I was super surprised that it was actually picked. And then after that, we started coding more complex stuff. So then I started learning Turbo Pascal because it was much faster. And then I started going into like more painting, more complex stuff, but not really game development. And then I've bought an Amiga 1200. And there I learned C, and I started coding
1200.
Yeah,
but I wanted to buy 500. And was Amiga 2000 as well? Was something like this? Amiga 2000? No.
There was also an Amiga 2000. So you had this 500, 600, 1000.
Okay.
The 1000 actually was the first Amiga, then the Amiga 2000, which was like a serious machine, and then the Amiga 3000 and 4000. Yeah.
And 500, what was 500? If you compare 500 to the others, this was like the mainstream, right, Amiga?
This was basically the, a very cost efficient version of the Amiga implementation, which was basically targeted for like home users that want to play games and so on. And the 1200 had more capabilities. It had a different CPU and also a CPU slot where you could put in turbo cards. So So basically accelerators with different CPUs, more memory, graphic cards, and so on.
Okay. And you bought the Amiga because you wanted to, because the 128 was not fast enough, or
Yeah, exactly.
Okay.
So, and then doing some serious coding. So I started learning C and then C++.
was C and C++ available on your Amiga?
Yes.
Okay.
There was this absolutely great Storm C compiler, which
Storm C.
wasn't that expensive, so you could easily afford it, and it had an editor, compiler, debugger, everything included.
Okay, so how much time you spent with coding and developing? Because
At
you
the
had school
moment-
as well. No, back then, you know.
Back then, way too much. Hours. I mean, hours over years, and then.
And which school you attended? Was it gymnasium in Germany or Realschule?
Yeah, exactly. It was.
Yeah, but
it was
still,
gymnasium.
gymnasium is somehow challenging. So, gymnasium in German, how it translates to US. So, what is gymnasium is a strange name because it means something different in US.
Is it high school or something like this? I don't know.
Because
to
in
be
German we
honest.
have two kinds of high school, right? So this one is like Realschule, is more, how to call it, more practical, right?
Yeah,
And gymnasium is
exactly.
more, you know, how to call it, not soft arts, you know, there's a technical branch, or this more like preparation for university, right? So
Yeah.
this is like this. And Realschule, you go there and do Fachhochschule, and the Fachhochschule is like preparation for applied science, University of Applied Science, or two exactly. And gymnasium is somehow more challenging. So how good you were at school back then?
Not really good.
Oh,
to be
very
honest.
good. So
I
at
mean-
least at least something, you know. So if you say just once, which are the best notes, then you know something wrong with me. But is it okay? So then,
Nah, I was really bad. I was really bad at school.
And math?
For math was okayish because and English later was actually not that bad because I started reading all those
Yeah.
English coding books. So yeah.
What's funny enough, I also started coding now early, but I couldn't see the point in math, and now it's interesting. If I look at the math formula or something, I see code, right? I see, okay, this is actually could be, but back then, the math is like, you know, something which no one needs, and code is the real thing. But right now, math is like almost programming for me. I always think, okay, this is cool. I could write a code, you know, for it.
Yeah, I mean, I had this one point in time where I realized, oh my God, math can help me so much because if you try to design a level for a game, how this usually looks like, you have those blocks which are repeating, which you can see. For instance, take a close look at Super Mario. There you see always structures that are repeating, and those can be represented by like an array, for instance. And then you have an array of numbers, and this is basically how you can do the basic level design of it. And then I've realized, okay, this is how I can represent my data, and this is why I basically actually need math.
Yeah, and even, you know, if you have a formula, you know, I don't know, X, Y, A, B, C, or whatever. Though I see variables right now, right? Okay, we can create a for loop and variable and a function, and it's done. But back then it was like somehow too abstract. I don't know. Maybe the teachers were different or whatever. But it's like, okay, this is not applicable, you know. But now it's very applicable.
Yeah, I mean, it really depends on the teacher. I totally agree.
Yeah, very cool. So I'm impressed. So I started to work with C and C++ to create a Paint Shop Pro or something like this.
Yeah, something like this. Because the Amiga had this. I played around with Deluxe Paint, which was the de facto standard paint tool for Amigas this time, and I wanted to implement something similar. And the Amiga had this very interesting graphics capabilities with the custom chipset which you could use. And then I bought this Amiga ROM kernel reference manual and API description books, which were like 1,000 pages of super complex mix of English and C codes, and started diving deep there. And that was a lot of fun. Problem was at this time, the Amiga was basically a multitasking operating system, but no memory protection. So this means in C++, if you made a mistake, you could easily crash the whole system by just overwriting some memory blocks.
This was also the problem with the first Apples, right? And maybe because they were based on the same architecture or similar architecture, because Amiga was 68,000, right?
Yeah, exactly, 68,000. But the thing is, the operating system was really small, super efficient, and had multitasking.
Was it Amiga OS, or what was the name?
Yeah, exactly, Amiga OS.
Okay. And your program or software, did it work, or you abandoned it?
I've abandoned it. So I've implemented a couple of functionalities, and then I stopped because I've realized, oh my god, this is so much work I have to put into this.
Yeah.
I mean, super hard to manage if you're the only person working on it.
How old were you back then?
I think 14 or so.
Oh, this is crazy. I mean, if you managed to do this would be even crazier. Yeah, cool. So I'm really curious. What happens then? So you, with 14, you knew C.
Yeah, I started learning C, exactly. And then...
And no problems with pointers and references, dereferences?
I went through hell, to be honest.
Okay.
It was like, especially pointers and references, I spent so much time on really understanding how this works. So do I have to pass a reference? And so on. And I've recently taken a closer look at Rust, and then I've noticed, still references there. Interesting. Yeah. And I mean, and then I stick with C++ for a long time, and then I've heard about this new thing coming up called Java, and it immediately caught me.
How old were you with the Java? Java 1?
18 or so. It was Java 1, Java 1.0.
Wow. Uh-huh.
And I mean, Java 1.1 brought a lot of enhancements so that you could actually use the language properly and the virtual machine. But it was like, oh my god, this is so cool, because you had this write once, run anywhere promise.
Mm-hmm. Where it was Java available on Amiga? No.
No. Then I bought a Mac, because then I had
which
Java.
one?
Oh, this was a Power Mac 6500 with 275 megahertz. This was one of those machines that looked a little bit wild and were limited when it comes to additional extensions, like you could put in an additional graphics card and so on, but it was sold with 50% discount. So I said, okay, this is my next machine.
Okay. But Java ran on it?
Yes.
Okay.
You had a Java implementation by Apple these days, and there was also a JVM implementation by, I forgot the name. This was also, MetroWorks.
Code Warrior.
Exactly.
ID.
I use Code Warrior.
I always wanted to test Code Warrior, but I never managed. Was it nice?
It was really nice to use. I mean, compared to Storm C, it was a big step forward, because it was so the debugging capabilities were much more enhanced, and it was way easier to write code with it.
Mm-hmm. What I wonder, I had lots of listeners, or guests, not listeners, listeners probably as well, but guests in the show. And they were low-level programmers, as you were, highly optimized code. And then Java came out, and they really liked that. I would say, if I started also with C and C++, but I was not that, it was later. So I started with Basic, 2 Pascal, and then I started with C and C++, and maybe 1 year later, Java came out. Mm-hmm. So for me, I still didn't like Java a lot, because C++ had, operator overloading, and the C in and C out, which I really liked, was like, this is great, these streams in and out, and I always overloaded my PaaS with, for instance, for metrics calculations or multiplies, or just fun. And then, the templates came out. I was also very, very interested in templates, and Java was very limited. So for me, it's okay. What I was intrigued with Java was more like, the design, the coffee. It's something, what's going on? It looks nice, and Sun Microsystems, nice company. They build, machines. So I knew that it is going to be big, but I didn't like the code. And apples were just stupid. So I couldn't understand why I was to spend time, to write something which moves in the browser. So, okay, this is completely pointless. And I got the idea later. So interesting that you like Java from the beginning.
Yeah, I mean, because the the reason for this was mainly that it was a very clean language. It was a very clean design. Of course, I mean, initially because of the limitations of the machine, things like ints were not really an object. So there was
this is
one
what I
compromise.
didn't even recognize that. For me, for instance, interfaces were pointless. But because in C++, this was nice. This was the header file was somewhere, and you could. This was for me, but I couldn't understand why I should use interface. I mean, this was like stupid, and multiple inheritance was not there. So just limitations without benefits at the beginning. Because of course, right. As C++ developer, I always had multiple inheritance just for fun. And Java, but. Yeah, this is interesting, but you're right. From clean, so maybe I like the complexity of C++. Say cool. No, you can just play the entire day with templates. I was not that industrial design like now, so just do the work and forget about that. I really like to play with it, right? So this is. And Java was less playful. It was just do the job and done, right?
Absolutely. I mean, it was stripped down initially for the bare minimum, and also covered some of the issues that C++ had. I mean, like operator overloading. I also like this, but I mean, if you don't look at your code for several weeks and then go back and see, okay,
and the project which is a hell. Just imagine, larger projects and developers start, to overload the operators. This is just in Java would be hell on earth.
Exactly. So, and what I also really liked was in the beginning AWT, so that I could just easily paint UIs. And then basically, Swing was also very nice because you could heavily extend it. So
but Swing came later, remember. So the first it was Come, Sun, Swing, and then there was a huge refactoring to JavaX, whatever. And I evaluated Swing for a company before Swing came out, so that we got like it was separate to Java. So we downloaded the Swing, and I remember the text fields were not properly rendered, so it was like one line was missing or whatever, but everyone was excited. So And what I remember, the big deal, why I got the Java projects at the beginning, so it was multi-threaded. That thread is inside the Java. This was a big deal.
True. Yeah.
Then we had at least at the beginning hash table, dictionary, and vector.
Yeah.
Which was not part of C++, I think. You had the standard template library, but there is no data structure inside. Later we got the Java collection framework. I don't know whether you remember. Yeah. At the beginning, I had to evaluate in projects which Java collection framework to use. So you had to buy them. There were all the collection frameworks. And then Java util collections came out and everything died.
You're right, yes.
And I forgot the names even. There was line Rock Wave or something like this. This was like one provider. And lots of, I have to look it up because there were nice companies. And there's a website, Programmer's Paradise. You remember this? Programmer's Paradise.
Yeah.
I know whether it was Gemma or not, but this is where we bought the stuff there. Yeah. Cool stuff, Sasha. So, okay, so you like Java with Mac, which is crazy because I had a Mac G4, and the G4 was not that good with Java back then, I remember. It was hard to get a newer one later, so it was actually terrible. And so I was curious what was the story, but I attended Java 1 in the year 2000, and for unknown reasons, no one remembers. I have the tape somewhere. Steve Jobs was on stage with Scott McNealy.
Nice.
And I actually, and Steve Jobs promised Scott McNealy that the Apple is going to be the best supported Java platform ever.
Yes, you're right. I remember, yeah.
And then I bought the G4, so late as you. But it was promised, but not really, so I never really used that. So, and I have to look it up because I taped this, and somewhere it is. This was the same Java one with lots of devices, but 2000 was that big that there were officially 30,000 developers, but it was bigger than this because they told the keynote. Officially 30,000. We cannot tell you how many because the fire department is watching us and we cannot admit that there's more than this. So there's actually a cool story. And all the hotels around Moscone were occupied with Java people.
Nice.
Okay, cool. Yeah.
I mean, it is. I bought a Mac at this time because I really didn't like Windows. So, and then after like a couple of months, I also bought a new used box to just run Linux, because at the university we had like those Sun Microsystems workstations and so on. And
you
so,
studied computer science after gymnasium?
Yeah, exactly. Started
cool.
studying computer
Yeah,
science.
sure. For me, it was, I never had Windows actually before, but because I knew I need C compiler, and for me it was clear it is not available on Windows for unknown reason, so I knew I had to buy Linux. So I assembled my own machine with Linux, and then I got the C++ compiler and lots of experiments. So at the beginning it was just a terminal, because there was no X window. I couldn't make it work, but then it worked. Okay, cool. So what you did with Java then? This is more interesting. So it was JDK 1.1, you said. It was 1997 we speak about, right?
Yeah, approximately, yeah. And then, I mean, at the university, the first programming language we had there was with Java.
Oh.
So, yeah, that was fairly new. It was in 98 or so, and they built this new computer science course. With a lot of hands-on, and then all the things we have done at university, or most of the things, were basically using Java. So, and then I started adopting it, and then after university, my first jobs were also somehow Java related, and then
At the university, what you did you did something significant with Java, or just the assignments, or you just enjoyed the university and forgot about programming?
No, I mean, I used to work for Siemens as a how's it called?
Intern?
As a student. Yeah, somehow. I mean, I had like a student job at Siemens, and we've built a system to manage your documents, basically. So,
was it Siemens Munich?
No, it was Siemens in Paderborn, because I studied computer science in Paderborn.
Okay. Because I also was a student in Siemens Authorized Java Center, but in Munich. So this is why I'm asking.
Okay, I see. No, unfortunately not. And yeah, we built this document management system, and this was completely built in Java. And I was responsible for some of those parts that were basically UI related, drag and drop stuff. So I played a lot with this Java Swing. So that was a lot of fun. And then this was basically my task.
Yeah, cool. So what happened after university, where you started?
In small company in a city called Erlangen, which is close to Nuremberg.
What's the name of the company, if you can?
It's called SpiritLink.
Okay.
And we were doing a lot of stuff for the Siemens those days, so Siemens Medic Care and so on. And then we started also building customer relationship management tools, also based on Java. And then this was basically the first time I had the chance to work with IntelliJ, and I was so impressed. It was so great. Yeah.
I also early, so I suggested idea IntelliJ back then. It was 2000, and before that I used JBuilder a lot. And after JBuilder, Eclipse actually, because Eclipse was very good with refactoring comparing to JBuilder.
Yeah.
And IntelliJ was always the problem that I'm a consultant. I had always to convince my clients to buy the license first.
Yeah.
And this was mission impossible for me, because in German companies, until the license is bought, easily you can, the project is over and you get approval for the license. Now it's better, but back then was terrible. Okay. Pretty cool. So SpiritLink, what you built, like server-side software, was it, or was
it was mainly server-side software? Yes, and then
you built your own server, or there were already J2E, or what do you use?
No, we've built our own server based on how is the servlet engine called? Resin, exactly.
Wow,
Resin.
POJO, the company, was one of the fastest. I think eBay ran on Resin once.
It was a facet at that time, and it could be easily extended, and this is why we picked it. And then I've dived deep into performance optimization, because at this point of time, if you had like two strings and you did a plus, then memory had to be copied and so on and so on. So
now no more, right? Now the compiler.
Exactly.
Yeah, that's interesting.
So we had to use string builder, string buffer, something like this. So we went through the code, did all that, measured how it performed, heap dumps and so on. So that was super interesting. Learned a lot.
Okay. And after the company?
Then I've joined Accenture and
Grow or go, right? This is the...
That was a really interesting experience. So I learned there a lot, especially about communication, how to speak with customers, how to do requirements gathering, all that stuff that you basically need, which also helps me these days.
You were also technical or just higher level?
Yes.
Yeah. Okay.
Technical consultant. So this was Accenture Technology Solutions. And we worked in the for a financial services customer in Munich, where we've built a risk management system.
Okay.
So
with Java. With Java.
Not really in the beginning. So it was based on C++ with Windows, which was a software that they've licensed. And we were basically responsible for the implementation of the whole orchestration. Like, okay, data coming in, data going out, market data, all that stuff. And then later, we've noticed, okay, we can optimize certain things because the reports had to be calculated overnight, which was a very challenging task because of the machines and how the data.
Yeah, batch processing, right? So these what host did in the night. There was batch processing, and during the day did something different.
Exactly, and there was an ETL program by the provider of the software, and this was one of the bottlenecks, and it was super slow. And I've taken a closer look at how this is actually working, and I did a completely clean room re-implementation using Java and using a few fancy tricks to optimize the runtime, also adding new capabilities for load balancing. So it could easily distribute the different contracts and so on for the different machines, so that you get same or similar runtime. So
okay, and this was the only project at Accenture?
That was going for 2.5 years.
Okay.
It was really huge project, a lot of different components, like starting from the mainframe and then later reports. So. Yeah.
Okay. And you quit Accenture after the project, so you can no more batch processing on a host.
Well, I joined another company. Was called Softlab. It's now part of NTT Data.
This was a BMW company.
Yes, exactly. It was a BMW company.
This was a great name, and they changed it from Softlab to something Cirquent.
Exactly, Cirquent.
Cirquent, and then it's like, why? Softlab was that great, and Cirquent was like, I mean, no one cares about. And Entity Data is okay because they're bought, but Cirquent, why you would change a name from Softlab, which is pretty cool, to Cirquent, right?
I don't know, to be honest.
Yeah, this is from marketing perspective is terrible, but I didn't knew that. So that you work for Softlab, because I did also some BMW and also work for Softlab from time to time as a consultant. When was it, as you spent time at Softlab?
Good question.
2000, I guess already 3 has to be, right? So if in 1997 you started with Java, let's say university 4 years, 2.5 years, so 2005.
Yeah, 2007, 2008, something like this.
Okay.
Yeah.
And what you did there at Softlab?
It was basically similar, or more or less the same, because the customer was really happy with my work. So, and they knew where I was going to. So they were asking, hey, we want to work with the Sasha again. And
cool.
Then I immediately had like a new project, which was basically the old project.
For Softlab?
Exactly, for Softlab.
Ah, okay. So you didn't work for BMW back then, just for...
No.
Okay.
Just for this financial services customer.
And you say, okay, again, the same project, so you quit then Softlab, right?
No, not really. Then I had another project at Softlab, and then another company approached me and say, hey, do you want to work for us, because we want to build a financial services department focusing on specific risk management things. And so I joined them.
Which was the name of the company?
MSG.
Oh, I also know, the MSG people. So there's the Markus Eisele is one of the MSG people.
Yeah.
He's works right now for Red Hat, but back then he worked for MSG, and they are all over the place. So I was invited even to Romania to us, for technology stuff consulting.
Really?
So yeah, they're all over the place right now. It's a huge company actually. MSG is in Munich, so Ismaning, and they are in I know Passau, everywhere. So
Wow.
huge company. Cool. And what you did financial again?
Exactly, financial services.
Okay.
Again, and BMW projects as well. And then a headhunter approached me and asked, "Hey, do you want to work for Allianz Insurance?"
So afterwards, you Allianz Versicherung?
Allianz, exactly, Allianz Versicherung.
Oh, okay. So I also spent some time
was-
there because I spent some time at Vereinte, which was bought by Allianz, and then a little bit by
okay.
Allianz. Also in Ismaning. This is at the same city almost, MSG and Allianz.
It's not Ismaning. It's how's it called?
But in the near of Ismaning, right?
It's close to Ismaning. I forgot the name, but it's close. It's same S-Bahn line if you want to go to the,
maybe
to
MSG is
the
also not Ismaning,
airport.
but this is very close to Ismaning.
Yeah, it is close to Ismaning.
Okay.
And there I started learning more about infrastructure because what we did was we've built. So at this point of time, they had a lot of WebSphere servers, right?
Exactly. And the department was called Agis or something, right?
I used to work at Amos.
Okay.
Allianz Managed Operations Services.
Something like this, because they had their own department which cared about WebSphere and stuff like that. Mm-hmm.
Yeah. And our task was basically to build a, let's say, a more cost-efficient version of a Java EE implementation using JBoss. And we did this together with Red Hat. And what we did was basically, so no manual deployments, everything automated. It's the customer's responsibility if something goes wrong or not. And that was super successful. I mean, was like people were buying our services like crazy because it was much more convenient to use, faster deployment times, also way cheaper. And yeah, that was a lot of fun. So I learned a lot about scripting, deployment.
What do you use
and so
scripting?
on.
You use Ansible or what?
Actually, we used a lot of Bash scripting these days. So I don't think that Ansible was a thing back that days. And we worked a lot with Red Hat, of course. There were always some folks from Red Hat over there, and we've implemented this together.
Around 2008, there was one commercial provider which used infrastructure. Was it infrastructure as code? It was like a scripting engine, and then Chef Puppet and all the others happened. It was around 2008, 2009. Yeah, so you built something like software as a service, the entire provisioning pipeline, right?
Exactly. Completely provisioning pipeline.
So almost serverless. So if you did it right, I could give you a war and you deployed that, right?
That was basically the intention of it. Yes. So
So this is serverless.
I mean.
From the model is serverless because I don't care about Wi-Fi anymore. I give you the war and just do something with it. I just focus on business, right?
Kind of, because the people still had access to the servers for the development stage, because sometimes they had to look up a couple of things. So it was not entirely serverless, but it was.
Yeah, but if you do a local stack with Lambda, is also you have something on your machine and similar story, right?
Yeah. So not entirely serverless, but really focusing on the application.
Yeah, but this is interesting. For me, it is actually 80% serverless because we had servers, but of course, the payment model was different because you had to pay something for month, I assume, depending on the number of CPUs or whatever. But from the idea, you only focus on business logic. You create a war. You have to follow some rules, and then you push the war to your pipeline, and you create with scripting the entire environment for me, and it runs.
It was more like a platform as a service offering.
Okay.
So yeah, but in the end, it was a very good experience for our customers, or for our internal customers, and also for us, because we could easily manage like 600, 700 virtual machines with just 2 folks. That was super nice. It was really great.
Yeah. And then you said, because it's so nice, I quit now.
Well, I mean, we had this very interesting idea. Hey, let's move to Berlin. And then I talked to the Allianz, and I said, hey, unfortunately, it's not possible that you can work from Berlin. So I had to quit, unfortunately, because the job was amazing. I really enjoyed it there. And then I started working at a company called Zanox, which is now affiliate Window, or AWin, which was in the basically it was advertising, performance advertising, it was called. So this means if you see like a banner for I don't know, a pair of shoes or something like this on the web page, so chances were really high that we were showing this.
Okay.
And there I learned a lot about latency optimization, because the latency, if you show a banner and if you click on it and do the HTTP forward, has a lot of influence on the conversion rate. So, and there I spent a lot of time with Vertex and implementing a tracking system completely from scratch. So we had like this legacy tracking system that was built with Windows servers and with SQL Server database and so on. And we were basically completely rewriting the whole stack using Java, using Vertex, using asynchronous I/O, decoupling, using Kinesis and Kafka and all these things. And
Kinesis and Kafka?
Yes, because some parts of the system were running in our data center and some parts of the system were running in AWS.
Already in AWS back then, it's not bad.
Yes.
Okay, cool.
And that was fully containerized. So this means even before Kubernetes or so was a thing, or even ECS existed, we were using Docker agent and then starting the container on EC2 instances using an immutable deployment model. That was really nice.
Yeah,
and
this is what in one project we have to set up some test instances. So this is what I'm actually doing right now. Use CDK infrastructure as code, EC2. I install Docker in the EC2 and can run it, for test purposes, and as a load balancer up front with a certificate, and it works. So it is because if you're running test software, you have still access to the shell via system manager, and ECS no more. So cool. This is why we met at Zanox, right?
Exactly. We met there because we wanted to do an enablement session for Java. Yes, exactly. And then we asked you, hey, can you do that? And then I also remember that we had this meetup in the evening, and we had to close the doors because people were basically storming our office, and we didn't have any seats left and no space left. So that was crazy.
And what was the purpose of the session? I also remember that there were lots of attendees back then. And it was a cool session because I remember there was a large room with columns, right? So there was I always have to move between so they see me. But it was a nice crowd. So you wanted to hire someone, or was it like?
Well, of course, one of the things was that we focus on hiring, and then also doing a little bit of community work in Berlin that days. So we thought about, why not?
Yeah,
it's fun.
This was nice. And what I also remember at Zanox is that I spent the night in a hotel in the near of the company. And the crazy stuff about the hotel was that it was by a movie company, I think. And inside the room, there was a music company, MGM or something like this. And they had Marshall amplifiers for guitar. So I could, in every hotel room. So I never saw such a thing. And I cannot play guitar, really. But I thought if I had a guitar, right, I could actually practice all night. And this was in the near of Zanox. So this was Zanox. And there was the hotel. And it was very strange because the hotel, I think, but MGM is movie. It was like hotel by a music company. It was just about rock stars and pianos and guitars and amplifiers, and it was crazy. I never saw such a thing actually.
Yeah. in the same building, I think, or
No, it was like 500 meters right.
Yeah, there was Mediaspray that day, so near Kreuzberg and in the Friedrichshain. So yeah,
Yeah, something like this. And and also interesting part, a guest of the show is Arjan Times, and he also worked for Zanox, seems like.
That could be the case, yeah.
Yeah. I say, okay, this is great, because I also had some experience with Zanox. And so what I did back then, I think I introduced, of course, Java EE and did some, but the feedback was incredible. So they asked me lots of questions, and we repeat even this session because there was not enough time. And so thank you for the invitation afterwards. It was like 10 years after.
Yeah, of course. I mean, that was really great. We really enjoyed it.
And so you spent the time, so you moved back to Vertex. I know you asked me some stuff about XML parsing or whatever. This was the issue with latency. I also remember, so we had a chat about that. And then you quit Zanox at one point of time, right?
Well, we worked. Of course, we had our account manager and account SA from AWS. Mm-hmm. And of course, we shared what we are going to implement, how this looks like. Had basically like a slide deck of the complete architecture and implementation and so on. And then they approached us and asked, "Hey, do you want to deliver a talk at AWS Summit about your implementation?" And then I said, "Yeah, of course, why not?" And then I realized I got the main stage in the big room, so I was a little bit nervous about this. And then they've asked me, "Hey, do you want to join AWS?" And then the whole thing basically started.
Okay, so you joined AWS. When was it?
It was 2015.
Wow, I didn't notice. So how I remember you again, I delivered a talk at the JCon conference, a nice conference, and you also were the speaker. And yes. I just saw Sasha. I was like, I know you from somewhere. And I remember the room with the amplifier, and then I invited you to the podcast. Like, we have to to speak about that because it was a nice experience. And JCon also great. It's going to be in Cologne this year. So also.
Okay.
So, and what you did at AWS? So, just Java related or?
No, I started as as an account solutions architect. So this means working directly with customers in the small and medium business segment. Mm-hmm. Back these days, it was called inside sales. So of course, supporting our customers and supporting our
what means support?
Managers.
I mean, it's like,
so this is. Let's say you're a company and you open your AWS account mm-hmm. and you start moving, for instance, your workloads and you need help. Then usually you approach your account manager.
Okay.
And if the account manager needs to dive a little bit deeper from a technical perspective, they include the account solutions architect in the whole conversation, and the account solutions architect takes a closer look at the architecture implementation details, and then gives a little bit of guidance about best practices and patterns, how things can be optimized from a security perspective, also from a price perspective, mm-hmm. and so on. So that's basically what we do as account solutions architect.
Okay.
Yeah.
So I always what I learned is everyone who has an account in AWS has a manager, and it can be dedicated or not, but you can always ping a manager and see what happens, right?
This is usually the case. I mean, we have so many customers that it's basically impossible to speak with each and every one. So we also have to think about, okay, how can we do enablement at a larger scale, which means writing blog posts, mm-hmm. giving conference talks about best practices and patterns and things like this. But if you are a company and if you have an account manager, then mm-hmm. usually you also have an account solutions architect, and then you also have like specialist solution architects, which are specialized in a certain technical domain.
Okay. But I guess you still saw lots of Java projects, right? No?
Yes. This is always, there was always my hobby, more or less.
Yeah.
So when I had the chance to speak with customers about Java-related workloads, I always made some notes, what they are implementing, what is working good, what is not working good, and then from time to time, I took this as input and started writing my own pet project and doing like implementations that could be released for guidance and so on. So I mean, one example was it was like 2 months. Every week I had with startups basically the same conversation about how to implement a tracking system. Then
Tracking of what?
Tracking or so advertising tracking.
Okay.
I said, look, okay, we can do a half-day workshop about this because actually I've implemented something like this before and I know exactly how this works. And then I said, okay, I don't want to have these conversations ever and ever again because it's repetition and I can spend my time better by doing a reference implementation, how something like this looks like. So I did this reference implementation using Vertex, using Golang, and so on and so on. And this has been released. And this is also, I mean, that is one of the things I really enjoy. So working with the customers, getting some feedback, and then thinking about, okay, how can this be improved? Getting feedback back to the service teams.
But you have to ask your manager, whoever, can I do this? And they say yes, it's a good idea or not, right? Or
yes. I mean, usually this is the case, and sometimes it is aligned with a certain initiative we're doing, and then it's just okay. I'm just doing it because I think it's a good idea.
Okay. Yeah, but recently you're doing more and more Java again, right? No?
True. Yeah. I mean, I spend a lot of time with things like Spring Boot and Quarkus and so on because we have a lot of customers that use Java in the context of containers. And sometimes they have challenges with this, for instance, startup times of their applications because they had their application running on-prem. Exactly. They just had one virtual machine, one server, and everything was fine because it was starting quick. And then they moved it to containers, and then startup time was basically an issue. Yeah. And this is why I spent quite some time on optimizing and getting also feedback from the different stakeholders and service teams and writing blog posts about this.
Because I have less experience with Spring and Spring Boot. Actually, no experience with Spring and Spring Boot. I always own one bug fixing project, and I spend all my time with Java. But I get always the question, as always, from time to time, about the startup time. Yeah. And what I notice is that the Spring Boot startup time is a larger issue than Quarkus or Micronaut. So it seems like it starts. So what's your experience? So you have some rough numbers. So I mean, because what I can tell you in all my projects, if you do AWS Lambda with one CPU, which translates to roughly 1.7 gig of RAM. So this is my standard thing. The Quarkus starts, if it's a large application, maybe in 2 seconds. And if it's a smaller application, in maybe 1.5 seconds without any optimization, just, right away, just write stupid code and start it. And I noticed, and I mentioned that, and they say that it's impossible. It's like, I mean, you can show you the numbers, and then I started to record, some videos because this is like it is. And what's the Spring Boot startup time as AWS Lambda? I'd say I would create, simple Spring Boot application. What's the times there? Do you have rough ideas or experience?
Not for AWS Lambda, because usually what I use with Lambda is this Quarkus directly.
Exactly. It's my problem as well. So
or just no framework.
Yeah, exactly. This is the second. Yeah.
Why should I use a big framework in the context of a Lambda function? But we've seen similar things when customers are doing this in the context of containers. So and I've written a blog post about AWS Fargate and then Spring Boot, and we've implemented 7 different versions of one application with different optimization levels. Okay. And we did some benchmarking and also showed how you can basically optimize for startup time. And then it really depends, of course, on your application.
Yeah, sure. What you do is you cannot say this, but there is some let's say basic overhead. This is what interests me. And And you compared the Spring Boot application with Quarkus or Micronaut?
No, it was just the different versions of the Spring Boot application. And then we measured, okay, how long does the application take time to start? How long does the complete provisioning cycle take time? And so on and so on. So it was a project over several months because it was quite complex, but all the code is also in GitHub. So
we put it to the show notes, of course. Yeah. Great. What you said, framework or no framework. So what I'm doing is I'm misusing AWS Lambda as a great runtime for monolith. So my functions are larger and larger. And no kidding, what I showed you, at Zanox 10 years ago or whatever it was, like an application on Whitefly with lots of classes, we package as a Lambda and it works great on Quarkus. So this is the one possibility that we are actually shipping microservices, if you will, on single AWS Lambda and it works perfectly. So the other use case for Lambdas is asynchronous Lambda. So I'm listening for notification to S3.
Yeah.
Let's say to Event Bridge, also common, or SQS, of course, classic Kinesis or SNS. And this, you are right, no framework at all. So this is what I really like. I have no dependency, so my Lambdas are tiny. This is the cool. So if you compare the size of Java Lambda with, say, Python or Node.js, they are smaller actually, because the bytecode is tiny. And what I'm using the SDK from Amazon directly. So I have a single dependency, the S3 SDK or DynamoDB or whatever. And yeah, the only issue I saw is that it seems like if you're using DynamoDB with Java, the startup times are slower, significantly slower than S3. So it seems like, the DynamoDB does something behind the scenes. I try to optimize it a bit with static initializer. So I was able to do this, I have to say, but still, it seems like, it creates some metadata behind the scenes or whatever. I will have to investigate this. But just not fault of Java, but how it is. But it works surprisingly well. And I always ask, why I'm using no frameworks, because I don't need dependency injection or whatever. I could, if you have, I have still nice architecture, like, I have the facade, and then classes, boundary control entity, what I always do, but it's just new. So there is no dependency injection. And I enjoy it because everything is unit testable. And the only the entry point is, of course, the entry point, if you get an Lambda event, or I use the Lambda input stream and convert it to JSON-B, for instance. So I can use event bridge events or whatever, and then pass it around. So this is very like servlets at the beginning, right? So very similar programming model, 1997 servlets, and lots of fun, no dependencies, and it works. I use even JDK 11. If you have called something JDK 11 HTTP client, built in, no dependencies, works great.
I mean, this is also what I suggest for a lot of customers.
Yeah.
That I mean, usually you don't have too complex logic in your Lambda function. So this means you can easily have your business logic implemented in a standard way, have it unit testable, and then you have like a small invocation layer that basically abstracts away all the Lambda specific parts. And then it's super convenient to use, super easy. And if you decide, hey, I want to move this to containers or to a different compute implementation, you can just use the existing business logic code and just have another invocation layer.
Yeah, absolutely. And by the way, you say complex. I would say why I'm using Quarkus is not because we write complex code. We write code with many endpoints. You know what I mean?
Okay.
So this is, we use HTTP API gateway up front with proxy integration. And it just delegates everything to Quarkus. Quarkus understands the HTTP event from API gateway, translates this to JAX-OS invocation, and I can have hundreds of endpoints, and the dispatching happens behind the scenes. But the code is not complex; it is cumbersome to implement. So this is like some Java E projects we migrated to Lambda in this way.
Okay, this is interesting.
So if you have the cool story is if you have an old Glassfish, Wi-Fi, Payara, WebLogic, WebSphere application. But it is written, as I showed you 10 years ago, no dependencies, clean code, and so far. So what you can do is Quarkus understands microprofile and part of Java E.
Exactly, yes.
So you can just run the same code locally and then try to package it and run it as Lambda. Works perfectly.
Okay.
And this is what I do all the time. This is what I told you why I need Quarkus always. Because this is all my projects. And the cool story is, developers really enjoy it because what I told you, serverless, what you did, at Allianz back then, it is almost the same experience. You create function.zip with CDK, push it. And by the way, we use full stack Java. We have one microservice. Inside the microservice is Lambda package and CDK package. There's one unit. If you run Maven, it deploys itself to AWS and is done. And Quarkus, because of no reflection and build time optimization, is crazy fast. And now with SnapStart is even better because I can with CDK automatically create the optimized image. So this is why I always need Quarkus for my regular HTTP endpoint projects, and Lambda is just a way to have less plumbing. I don't have to care about VPC subnets and security groups. I just focus on my business logic, which is, by the way, exactly this is what I did with Java EE. This was my interest in Java EE, and now I do the same with Lambda. And the other way of Lambdas is I don't like to have Quarkus if I already get an event from AWS, right? So if AWS emits an event, I can subscribe with a Lambda, and I don't need Quarkus anymore because there is nothing to dispatch. So this is my two architectures I do right now.
This is a really interesting migration path. I always thought, okay, if you have a standard Java EE application, then it is basically migration target would be containers because you have a stateful application and so on and so on. But migrating to Lambda is very interesting.
Yeah. Actually, stateful EJBs were not that common. And I maybe you're interested. I delivered a talk 2 years ago for DevOps. It was online. Mm-hmm. It is somewhere out there. And it was like the title was like, EJB developers, now is your time. And what I did is I explained Lambda with EJB ideas, and they are identical. So if you're an EJB developer, this is, for instance, max pool size is not provision concurrency, the reserve concurrency. So you say, okay, there are at most, 10 instances running. Then min pool size is actually reserve concurrency because you would like, to keep your Lambda warm as you did with EJBs. Then if EJB crashes, it was recreated. If Lambda crashes, it's recreated. Then, so this is one-to-one mapping between EJB ideas and Lambdas. And I got actually good feedback, and they say absolutely clear. And this is what I use in my projects to migrate the old enterprise projects to serverless environments. And of course, right now with CO2 and energy efficiency, I get actually more projects that I can handle because in most enterprise projects environments, if you think about this, so what they have, I know my clients, if they have code written as I said, no dependencies, just no reflection. By the way, reflection was also forbidden in EJBs. You are not
true.
Yeah, a file access forbidden by EJBs. Synchronize was not allowed by EJBs. So if you just consider the programming restrictions back then, you have great Lambdas. And the only thing which you have to be aware of is that the the containers were multi-threaded, and Lambdas are process-based. So what doesn't work, you cannot cache data in static, right? But this was the same in EJBs. If you run in a cluster, was over. So because it was you were in this bean and in the other bean, so it was a cluster with load balancing. You have exactly the same problems with Lambdas. But this is why I do Java EE more than ever before, but in serverless environments. And clients are delighted because if you think about typical enterprise application runs from 8 to 5, and that happens nothing at night. So we pay for day and nothing at night. And if they have to spin up Kubernetes clusters, they have to pay 100 euros for control plane or whatever, and then for the worker nodes. And the next story is, Sasha, if you think about this, every developer can get an own account, right? So you get the entire dev environment for free in serverless, but you cannot create a Kubernetes cluster per developer.
This is a very interesting approach. Let me think about this because
do it for 3 years. There's nothing to think. You have to do this, so it works perfectly. Don't tell anyone. So this is my my top secret migration.
Oh, okay, interesting. Yeah,
I wrote an article for AWS. There was like a blog, and in this article, I also said, let's see what happens. So I describe, this is what I'm actually doing.
Yeah, this year one of the things I also want to do is to spend a little bit of time on those migration topics, like when my customers still have their Java EE server running, and how could a good migration look like. So this is very interesting.
Only problem is GSF, so you have to do something with it. But of course, it's front end. But the back end, checks it. Listen, it was nice to meet you now again after 10 years. would be nice if you could send me, all the references you have to your articles.
Sure.
I will just put my articles there, like EGB or so, and you will see this, you will find this. It was a really nice session with you. So it was fun. And I was surprised about your background. I didn't knew. So we were very close to each other, but we met in Berlin the very first time, which was crazy.
Yeah, this is always the same. Like, if you speak with people, it's like, oh, I know this guy as well. I know those folks, and actually you've never met, but
yeah,
you
I worked a lot with Softlab, with Allianz, all the companies. I never met you, and I met you in a complete different company at Zanox, and Aryan Times, which is now he's on Omnifish. He creates own startup company, but he was guest on the podcast, and he was Jakarta security spec lead. So he's actually a famous guy. He worked for Zanox a long time.
Really interesting.
Yeah.
Really interesting.
Thank you. So where people can find you on internet or, reach you?
Twitter, LinkedIn is always the best. So it's Sasha242 for Twitter. So DMs are open if you want to have a chat about, I don't know, certain AWS specific things like containers and so on. Please let me know. And then LinkedIn, just search for my name.
Yeah, and what I did recently, because I was asked by attendees, is I created a Discord server. The name is Airhacks. And the Discord server is public, so you can join, but you have to be nice. So this is one of the rules, productive and pragmatic and nice. And there are already a lot of members. There's lots of fun. So if you like, just join. Listener and you, Sasha, you can just join the server. There's nothing to do. Just join and have fun with us. Okay, thank you.
Cool. Thank you very much for having me today. It was really nice. And 1 hour is already over. This is
time flies, right?
Exactly.